Hey friends, welcome to TechHarvesting. In today's video, we're gonna have a look at how we can create variables in Rust. So this is the second episode of my Rusted series, and in this video, we'll have a look at creating variables with the let or const keywords, and also we'll have a look at the different data types in Rust, like integers, characters, booleans, and more. So let's get started. Now there are two main types of variables. The first one is a normal variable, and the other one is a constant. So let's first have a look at creating a normal variable. So for creating a variable, you use the let keyword. So let, give the name of a variable, my var, and it's recommended to do like this in Rust. You have to give the snake casing, so after each word you have an underscore and no caps, and then you can give equals and give the type or the value of the variable. Now by default this is inferring it as I32. Now soon we'll have a look at the types, the data types in Rust, but first let's have a look at creating these variables. So now that's created. Now if you go under this, you can see that it's not used, so you can just print it out. So again, we're using the println command, and here for printing a variable, you add empty braces, and you go here, make a comma, and give my var. So it will replace everything in this brace with the thing you give here. So if I run this now, you can see we get 8, which is the value here. Now instead of being a normal number, which is a positive integer, you can make this a negative integer, and it should work well. As you can see, we get -8, and you can also go ahead and make this a float, so -8 point a decimal number, and if you run it, it still works fine. Now that's how you create a variable and print it out. Now next, let's have a look at creating constants. So for that, use the const keyword, and then you give everything in uppercase for consts. So my constant equals, and you give this. Now one thing you should note is that you should go ahead and give the type here. So for now I'm going to give F32. We'll discuss about this soon, but it's just how we are typing the variable. If you go here now, we can give in my constant, and if we run it, obviously you can also do cargo run, it works the same thing, and you see we get -8.543, which is what we gave here. Now one thing you have to notice is that if we were to go back to our variable and we give my var is equal to -5.3, for example, and also remember that you should give semicolons at the end of each line in Rust. It's mandatory. But if you look here, you can see that cannot mutate immutable variable my var. Now this is because by default variables in Rust are immutable, which means it cannot be changed. So if you want to change it, you should give the mut keyword here, and now it should be able to be changed. Now if you look at this, the warning it shows is because we are changing it here, and there's no really use of changing it. So I'm going to copy this and paste this here. So first we should get this value, and then we should change the value of the variable, and we should get a new value. Let's run it, and as you can see, first we get the default value we gave, then it's changing the value to -5.3, and it's running. So that's how we can create a variable, change its value, and we also have a look at constants. Next, let's have a look at the different data types in Rust. So for that, you can go here onto the Rust documentation. I'll leave a link to this in the description. So here all the main data types in Rust are given. So there are two main types, the scalar types and the compound types, and these are the part of the primitive types. It means the types which are built into Rust. So these are the main types. There is the integers, the signed and unsigned. So basically a signed integer is an integer which is going to be positive or negative, it doesn't matter, but an unsigned integer is always positive. The floating numbers are the numbers with decimals. Characters, so these are just any string value with only 1 byte. So, or 1 byte, by that I mean like one character. So for example, we can have like this, so just one character in it. So that's the char value, char type, and then there's boolean, which is true or false, just like any other language. So let's have a look at each of them. So I'm gonna go ahead and clear my code. And first let's create an integer. So let my int, and here we can give a value, and so we need to give this one's type first. So for that you can give a colon here and give I32. So this means this is an integer 32 type, and it can store a certain amount of values. So if you go here, you can see the minimum value of an I32 is going to be here. So it can be negative 2 raised to 7 to 2 raised to 7 minus 1. That's my value. So that's for I8. So since we're using I32, this is the value, the minimum and maximum. I'll leave a link to this also in the description, so you can go ahead and refer this. So if you look here now, you can go ahead and print it out. So and if you run it, you can see this is working fine. Next, let's go ahead and create a negative integer. So let my neg int, you can give the same type and give the semicolon. Now if we print our negative integer and run, you can see we get negative 10. We also get this warning because this variable is unused right now. That's fine, you can just comment it out. Also in Rust, comments are just two slashes, just like many programming languages. Now here the I32, for example, we can use an I8 also, since minus 10 is a small number, but if we're using a big number like this, it's not going to work. As you can see, I8 doesn't support huge numbers. So here you can go like 120 or something, it should still work. Next, let's have a look at the uint. So I'm going to comment that and create a new variable. Let my uint equals 10, and let's print here my uint. And this my uint is going to be an unsigned integer. So if I were to run it now, it should work fine. But if I make it a negative value, now let's make this a uint. So u32. Now if you see, it's screaming at me because it's a negative number, and unsigned integers support only positive numbers. So always remember that when you're using uint, you're always going to be using positive numbers. So let's change that back. And next, let's have a look at floats. So again, I'm going to comment that and create a float now. Let my float equals 6.4, and let's print my float. So by default, this is the F64 type. There's also an F32, and this should work just fine if we print it out. Yep, as you can see. And we can also make this an F32. It should still work. As you can see, no errors. And also this supports negative numbers. It's going to work just fine. The next scalar type we're going to have a look at is the character. So we can go ahead and create a new variable called my char, and then you can make it a character. And you have to be using single quotes for characters, so that's mandatory. And here you can change it as my char. So you can once again go ahead and run it, and as you can see, we get our R there. Now the last of the scalar types is the Boolean. So that's also very popular, almost there in all the programming languages. Just a true or false value. So let my bool equals true, and you can see it's default to a Boolean, and if we run it, we should be seeing true. Next, let's have a look at tuples. So tuples are a feature where you can create, it's similar to an array, but it's having fixed length and it's having different types of values. So for example, let my tuple equals, and you're going to be using normal parentheses and no square brackets here, and you can have 54 a character, and maybe you can also add like a boolean, so just like that. And you can see it's inferred the type automatically here. It's just going to be an I32, oops, an I32, a character, and a boolean. So we can maybe make this an I8 since that's all it is, and that's going to be a tuple. Now the thing is, you cannot print this tuple directly, so if we were going to do a print ln and we give it like that, we can't just print my tuple. So if you run this, it'll give us an error. So now what we should be doing is we should give a dot, and we can give the index of the value. So just like any language, the first item is index 0, the second is 1, third is 2, and so forth. So if you look here, the first number 0 is going to print us 54. So if you look at the first index and print it out, you can see we're getting 54. The same way, if you give 1 here, we should be getting R, and as you can see we get R. So that's basically what a tuple is. Now also, like the other variables, you can change the values. So if I just go ahead and give my tuple dot 0 equals 3, it should shout at me because this is not a mutable variable. So let's make it a mutable variable by adding the mute keyword. And if I run this again, oops, I'm printing the first, so let's print the 0th index, and that should work. There you can see it's printing 3 now because we changed the value. You can also redefine the entire thing, so if you're not going to any index, you can just do this and completely change all the values. So 3, S, and false, and this is giving the error because we are changing it without any use. So let me just do that, dot 0, and let's run that. Oops, the semicolon, and 1 again. As you can see, first it's 54 and then it's 3. Also I can print the second one, or the first index. So if we do that, you can see in the beginning it's an R, and when we scroll down we change it to an S, and the S is coming here. So next, let's have a look at the arrays. So I'm going to create an array here. Let my ARR equals 0, 1, 2, 3, 4, and we're giving a semicolon, and we can again print it like usual. So we can go ahead and give my ARR, and obviously we should give the index of the value, just like the tuples. And if we run this now, we can see we're getting 0, which is the first one. Now there's a small difference between arrays in Rust and other languages like Python or JavaScript, because in Rust we can have only one kind of one data type in the array, so we cannot have different types. So all of these are integers, and we're going to be having a fixed length. So as you can see here, there are 5, and if we give one more element here, you can see the length is 6. So again, we are able to change it here. If we make it 0, then it should be an empty array, and if we make it 7, it should be having 7 items. There you go, and that's how it works. So we are not able to change a specific the length of the array. Again, like anything else, you can change the values. So you can have my ARR 4 equals like 9 or something, and then if you print the 4th element, it should give us 9. Oh, I forgot the semicolon again, so let's run it again, and you can see it gives us 9. So this is important. First you give the data type, you put a semicolon, and then you give the length of the array. Then you're giving the type for the array here after giving the variable name. That was it for this video. We had a look at creating different variables using the let or const keywords, making variables mutable, and also different data types like arrays, tuples, and more. Thanks for watching, and make sure to subscribe for more such videos. I'll see you in the next one.